Partial derivatives. What does mean by partial derivatives? We obtain a derivative of a function f of several variables x, y, with respect to one variable, say x, while keeping the other variables as constants. This derivative is called the partial derivative. This is denoted by fx or partial differential f, partial differential x. The partial derivative of f, x, y, with respect to x at the point a, b, is we can write using limits like this. Notice that f, x, b, must be continuous at x equals a. Graphically we can represent fx like this. It is tangent line to surface with respect to x. What is partial derivative with respect to y? We can write this as well with respect to y. But notice that function must continuous at point a, b. Let's go to an example. Alright, let's tackle this problem step by step. We need to find the partial derivatives of the function. Partial derivatives measure how the function changes as we tweak one variable while keeping the other constant. Let's break it down. For the first term, which is 3 times x squared multiplied by exponential of negative 2y, notice that the exponential part is treated as a constant when differentiating with respect to x. So, the derivative of x squared is 2x, and the constant part remains unchanged. For the second term, which involves the sign of x multiplied by y to the power of negative 2, remember that the y term is treated as a constant when differentiating with respect to x. The derivative of sin x is cosine x, and don't forget to keep the negative sign from the original term. Now, add both results to get partial derivative with respect to x. This time, the term with 3 times x squared is treated as a constant because we're differentiating with respect to y. The derivative of the exponential function e to the power of negative 2y is negative 2 times e to the power of negative 2y. Remember, this comes from the chain rule. The sign of x is treated as a constant because we are differentiating with respect to y. The derivative of y to the power of negative 2 is negative 2 times y to the power of negative 3. Be careful with the signs, the original term already has a negative in front. And there you have the partial derivatives. Combine both terms for the partial derivative of the function with respect to y. And that's it. You've just mastered partial derivatives step by step. Great job following along. I know math can be tricky, but you're crushing it. Glowing star if this helped. Don't forget to like and subscribe for more tutorials. Thanks for watching, and have an awesome day. Smile. See you in the next video.